Have you ever been coding along, things seem okay, and then bam, your program just crashes. You get that infamous, that dreaded null pointer exception.
Yeah.
It's like your code hits a wall because something it expected. Well, it just wasn't there. They call it the billion-dollar mistake in the software world. And for good reason.
It's definitely caused a lot of headaches.
Well, if you're a Java developer or maybe just curious about how programmers deal with these kinds of frustrating issues, you're in for a treat today. We're doing a deep dive into Java's optional class.
Right. Java 8.
Exactly. Introduced in Java 8, specifically designed to tackle that null nightmare, sort of head on. So our mission for this deep dive is pretty clear. We want to unpack exactly what optional is, explore why it's seen as such a game changer for writing safer, clearer Java code, and crucially, arm you, the learner, with what you need to start using it effectively, without falling into some of those common traps.
Definitely. And maybe to help wrap your head around it, think of optional like a special container, a box.
A box. Okay.
Yeah, and this box either holds something inside it, a non-null value, like a number, a string, whatever, or it's just empty. But what's really insightful here, I think, isn't just stopping crashes, it's how it changes your design philosophy.
Ah, okay. How so?
Well, it makes the absence of a value a sort of first-class citizen in your API. It shifts the burden, from the person using the code having to remember, oh, I better check for null, to the person writing the code explicitly signaling, hey, this might be empty.
Right.
And that small shift, it makes your methods much more robust, more self-documenting. It's like a contract in the type signature itself.
That's a fascinating way to put it, a shift in design philosophy. So the core benefit isn't just fewer crashes, it's also about making the code itself, well, more expressive.
It tells you what to expect.
Okay, so let's start right at the beginning then. What is optional, fundamentally? And, what problem was Java really trying to solve when they brought it in?
Right. So at its core, optional is a class. It lives in the java.util package. And its whole purpose, really, is to represent a value that might be there or it might not. Like we said, it's a container. It's either holding a real non-null value or it's empty. That's it. And its introduction. That was a direct response to the null pointer exception.
The billion-dollar mistake again.
Exactly.
Yeah.
Offering a safer, much more explicit way to handle absence compared to just using null. It's really part of Java's evolution, trying to deal with potential emptiness in a more robust way.
I see. And the sources we looked at, they highlight some key features.
Mm-hmm.
What does optional encourage developers to do? Or maybe what does it encourage them to avoid?
Certainly. It actively pushes you away from those direct if something null checks, because those are often where the errors creep in, right? Instead, it guides you towards a more explicit handling of absence. You have to consciously deal with the empty case. And it also really supports a more functional programming style.
Ah, functional programming. Can you elaborate on that a bit?
Sure. It means you can chain operations together on the value inside the optional in a very concise way, without needing lots of separate if checks scattered around. It fits really well with how modern Java is evolving, especially with streams.
Okay, so it's about safer code, better style. Makes sense. What really gets interesting then are the practical reasons. Why is it used so much in real-world code? What are the big wins for a developer?
Oh, the benefits are quite significant. First, and maybe the most obvious one, is it seriously cuts down on null pointer exceptions. By forcing you to think about and handle the empty case, it just slashes those unexpected runtime crashes. Debugging those is no fun.
Tell me about it.
Second, it really improves code clarity. When a method signature says it returns an optional something, it's a clear signal. Anyone reading that code immediately knows, okay, this might not return a value. It's self-documenting in a way.
That makes sense. No guesswork.
Exactly. Third, like I mentioned, it enables that more modern functional programming style. It plugs right into the Java Stream API, which is Java's way of handling sequences of data. It gives you elegant ways to work with potentially missing values, much cleaner than nested ifs.
Right.
And finally, it helps standardize how you handle nulls, or rather absence, across your whole project. Consistency, makes the code much easier to maintain in the long run.
I can definitely see the real-world value there. I remember pulling my hair out once debugging an MPE just because a database query came back empty. So when would you typically reach for optional? What are those classic scenarios?
Yeah, those database issues are a perfect example. Definitely use it when fetching data from a database because maybe the record just isn't there. That happens all the time. Or parsing user input. That can often be messy, incomplete, right? So values might be missing. Even a simple method, say, finding an item in a list. If it might not find it, returning an optional is the clean way to signal that. It's really about explicitly communicating, hey, this might be empty, instead of just returning null and hoping someone remembers to check.
Okay, we've talked a lot about why it's important, why it's a solution, but how does this smart wrapper, as you called it, how does it actually work? What are the mechanics and the core advantages driving its effectiveness?
Well, the advantages really come from how it's built. As we said, it consistently cuts down on null pointer exceptions because it forces you to consider the empty path. It makes your code intent clear. Seeing optional tells you immediately this might be absent. It strongly supports functional programming with methods like map, filter, orElse. These let you write really concise logic.
Instead of nested ifs.
Exactly. Which leads to improved readability, usually. Chaining operations is often much cleaner than deep if x null blocks. Plus, you get that consistent handling of absence across your codebase. A big win for maintainability. And it provides really easy ways to give safe default values using methods like orElse or orElseGet if the value isn't there.
That's a strong list.
Yeah.
But I'm still curious. Let's unpack this a bit. How does it actually work internally? What's going on under the hood?
Good question. Internally, look, it's just a regular Java class, java.util.optional, nothing too magical there. It's designed simply to wrap a single value of whatever type you need or to be empty. So it basically exists in two states. Either it's present, meaning it holds a non-null value, or it's empty, no value inside.
Right.
Simple as that.
And how do you create one?
You use specific factory methods. If you know your value isn't null, you can use optional.f value, but be careful, that throws an exception if you pass it null. So more often, if the value might be null, you use optional.of nullable value. That's the safer, more common choice. It handles null gracefully, creating an empty optional. And if you want to explicitly represent emptiness, you just call optional.empty. Oh, and importantly, it's immutable. Once you create an optional, its state empty or present, it can't be changed. That gives you predictable behavior.
Okay. And what about using the value or checking if it's there?
Right. It comes with a set of really useful methods. IsPresent is the basic check. Is there a value in here? Returns true or false. Then you have methods to get the value out or handle the empty case. orElse, default value is common. It gives you the value if it's present or your specified default value if it's empty.
Handy for fallbacks.
Very. There's also orElse supplier. Similar, but the default value is computed lazily using a supplier function. That can be better for performance if creating the default is expensive.
Interesting.
And you've got methods like map function. If the optional contains a value, map applies the function to it and returns a new optional containing the result. If it was empty, it just returns an empty optional. Great for transformations. And if being empty is truly an error condition for you, there's orElse throw. It gives you the value if present, otherwise it throws a no such element exception.
It forces you to handle it somehow.
Exactly. Now, it's crucial to understand optional itself doesn't magically stop null pointer exceptions at runtime by, intercepting them. What it does is its API encourages or even forces you, the developer, to think about and write code for the empty case. That's what prevents the errors.
It guides you towards safer code.
Precisely. And since it's just a standard Java class, it generally plays nicely with common frameworks like Jackson for JSON handling or Spring for building applications, usually.
Okay, this is great. It sounds incredibly useful.
Right.
But here's where it gets really interesting, right? While optional is powerful, no tool's perfect. What are some of the common pitfalls? Where do people, especially beginners, tend to misuse it?
That's a really crucial point. One of the absolute biggest mistakes is trying to use optional as a blanket replacement for null everywhere.
So not for everything.
No, definitely not. It's not generally recommended for things like class fields or method parameters. Using it there often just adds boilerplate and complexity without much real benefit. It can actually make the code harder to read, ironically.
Okay, good to know. What else?
Well, there's a bit of a learning curve, especially those functional methods like map and flat map. If you're new to functional programming concepts, they can seem a bit confusing at first. There's also a small performance and memory overhead. It is a wrapper object, after all. Now, for most applications, this is totally negligible, but in really high-performance, low-latency systems where you're creating millions of these, maybe it could be a factor to consider.
A minor point for most, then.
Generally, yes. Another thing is, sometimes for a really simple null check, using optional can feel a bit verbose compared to a quick S null.
Right, more typing.
Potentially. Also, serialization. Some frameworks, especially older JSON libraries, might not handle optional types automatically. You might need to add custom serializers or deserializers, something to be aware of.
Okay.
And finally, there's a risk of ending up with nested optionals, like optional string.
Oof, that looks confusing.
It is. It usually happens if you misuse optional.ofNullable on something that already returns an optional. Then you need extra steps, like using flatmap to sort of flatten it out. It's usually a sign you've done something a bit awkwardly.
Okay, so those are definitely things to watch out for. So bearing those pitfalls in mind, what's your core advice for someone just starting out, someone listening right now, wanting to use optional effectively?
Right. For beginners, the absolute most important takeaway. Primarily use optional for method return types.
Return types, got it.
Yes. That's its sweet spot. When a method might not return a value, like a find user by ID method returning, optional user is perfect. Explicitly try to avoid using it for class fields or method parameters. It usually just complicates things. Stick to return values first.
Makes sense. Keep it focused.
Second, always handle the empty case explicitly. Use the methods optional provides, like orElse, orElseGet if present, or even orElse throw if an empty result is an error. And please, strongly advise against just calling .get directly.
Why that?
Because if the optional is empty, .get will throw a no-settlement exception. You're basically trading one potential exception, null pointer exception, for another. Only use get if you've already checked isPresent or you are absolutely 100% certain it's not empty.
Okay, so avoid raw.get. Use the other method.
Exactly. Start simple. Get comfortable with isPresent, orElse, and orElseGet before you dive too deep into map, filter, and flatmap. Build up gradually. Remember, it's not a default replacement for every null. Reserve optional for situations where absence is a meaningful expected outcome, like that database query not finding anything. Don't just wrap every single variable.
Don't overuse it.
Right. As you get more comfortable, do learn map and flatmap. They are powerful, they align with Java's functional direction, and they're key for chaining operations elegantly. Also, always double-check compatibility when using optional with frameworks like Spring or Jackson. Just glance at their docs to see how they handle it. And remember, it integrates beautifully with Java streams. Methods like find first on a stream, return an optional. Practice using them together.
Good synergy there.
Definitely. And finally, strive for readability. Yes, optional can make things clearer, but excessive chaining or really complex functional pipelines can sometimes make code harder for your teammates to understand. Find that balance.
This has been incredibly illuminating, really helpful. So wrapping up, what we've really learned today is that optional in Java, it's a genuinely powerful tool. It helps manage potentially absent values, significantly cuts down those awful null pointer exception risks, and it pushes you towards clearer, more expressive code, especially with that functional style. It gives you a standard, clear way to say, this might be missing, and handle it gracefully. That feels like a big step up for writing robust software.
Exactly. But the key, as we discussed, is thoughtful use. It's not a silver bullet. It requires care to avoid adding complexity or just using it inappropriately. So focusing on its main job method return types, always handling the empty case properly, and then gradually exploring those functional methods while keeping an eye on framework integration. That's the path to using it well. That leads to much safer, much more expressive Java code in the end.
Fantastic. So a final thought for you, our listener. Now that you understand how a seemingly simple concept like optional can elegantly tackle a major headache like null pointer exceptions in Java, maybe consider what other common problems, perhaps your own field or even just in daily life, can be managed better with a similar kind of container thinking. That idea of explicitly representing a state of present or absent. How might that concept of explicitly handling possibility apply beyond just programming? Something to chew on.